Very nice.
Hello, Mystic Wonder fans. We're back here. This is my friend Nick Jurisic, and we're going to be talking about the philosophy of mathematics. It's actually more interesting than you might think. I'd like to start the conversation out with an idea I had that I call antizero. And antizero is the reciprocal of zero. So it's 1 over 0. So you have 2 and a half, right? Those are reciprocals. 3 and a third, 4, a fourth, 5 and a fifth, 6. So you go a million and a millionth, billion and a billionth, infinity, infinitesimal. But that's where it breaks down. Because what do we call 1 over 0? Undefined. So 0 is reciprocal is undefined. But what if we could define it? What do you think, Nick, of this proposal that we could possibly define 0? Let's start right from there. Is it necessarily undefined, or could we define it? Because Nick here, I think actually your credentials are he has a master's in mathematics. So just so you know, he knows what he's talking about.
That's what they're calling us nowadays, a master of mathematics.
So could 1 over 0 be defined?
Anything could be defined.
Right, because math is arbitrary.
It is. All definitions are completely arbitrary. And so the question is the matter of whether one could make a definition that people would consider someday useful. I mean, sometimes people define things and then they're not accepted at first. Antizero could be like that.
The validity of mathematical truths are whether they're useful, or is it whether they're true?
I mean, validity in the logical sense is like about the structure of the argument.
Sure.
Right?
But
then there's like the validity in the colloquial sense of, I mean, math is positioned as objective, but like anything else, it's subjective, and it goes with the times. And I mean, look where the money goes, for instance.
It is very much based on subjective intuition and understanding of mathematical theorems and axioms. And math is in a way subjective because it is arbitrary in the sense that it's all based on definitions that we arbitrarily create based on our own ideas. What is 2, 3? They are ideas, no?
So people...
Unless you're some kind of mathematical realist.
Mathematical realism.
Like a Platonic view in which mathematical objects exist somehow as abstract objects in their own Platonic mathematical realm, and that math is not merely invented but discovered. What do you think about that?
I'm never sure what to think about it. It's like is math invented or discovered? Question. Could be both or neither as well. Do these things already exist?
That's interesting. It could be both or neither. I hadn't thought of that. So maybe that's not either or. He's thinking it's a mathematician.
It's all actually about even what you define math to be. I mean, that's a hard question in itself. Mathematicians joke, and maybe they're serious. I don't know. They're like, "Oh, math is what mathematicians do." And, mathematicians are people who do math. So there's that.
Right. Is math a language to describe reality? Is math something more than that? Some kind of abstract logic to the universe?
John von Neumann said that mathematics may be a secondary language built on the primary language of the nervous system.
I guess it definitely is a language. The question is, does that language also reflect something objective, independent of the ideas?
I've recently taken like the socio-cultural view on it, that math is always situated within our practices, as humans. And you could argue that like insects like bees or animals have something mathematical, like things that aren't human, and you could argue
bees
like
have math
instincts
because they can communicate distances.
Like if you always know like where the sun is or something to that effect. And you could argue like they have
It's
some sort of internal
implicit
compass, but
mathematics.
are they doing math? Like it's sort of
I guess we
debatable
can't
as
know.
well.
What is it like to be a bee?
Right?
It's a mystery.
I mean, if you take like a behaviorist viewpoint, I still don't really know what they would say about that, but like maybe like the first order, if you just look at the behavior and say like behavior reflective of mathematical principles, one could argue with that. If that was your definition of doing math, then yeah, I guess a lot of things are doing math.
Things are doing math.
People.
Could a river be doing math?
Could a river be doing math because it's taking the least effort in its actions? I mean, that's the whole principle of least action.
Could there be something computational about the way water flows down a river? Or at least implicitly mathematical, because if you described the laws governing the water flowing in a river, it would be mathematical. Are all physical laws mathematical?
Yeah, that's a good question. Ultimately, it reminds me of like, is everything physical, but B, can everything that's physical be described by math, like you said? Can everything be described by math? Are there things which cannot be described by math? Can love be described by math? Can consciousness be described by math?
Well, the phenomenal experience, I would argue, no. How could it possibly be captured in mathematical terms? It's a direct experience. You have to be acquainted with the experience, because the experience is the knowledge. What is it like to experience X, experience red, experience love? Well, the experience of it is the knowledge of what it's like. And so, no, it cannot possibly be grasped in mathematical terms nor physical terms. But that doesn't mean we can't construct a physical mathematical theory of how these experiences work physically and how they interact with everything else within a model of physics.
Yeah.
The experience as a token can be identified as a mental state and a brain state, probably. The experience of love, right? Should be a brain state.
Probably, but then there's a part of me that wonders.
Experience of red. What is experience of red? Is more simple, maybe. It's a visual cortex pattern. It can be described physically. But what are we describing except the explanation of how it works, how the structure of it fits in with the structure of the rest of the universe? But what is the experience of red, right?
Yeah.
That is the phenomenal knowledge. The qualia, yes. And qualia is simply knowledge, because it's knowledge of a certain experience, a certain what it's like, a certain phenomenal consciousness. But getting back to antizero, which is what I wanted to focus on. Okay, so antizero is reciprocal of 0, 1 over 0. Now, this is the best way I thought of explaining it was, so you have y equals 0x. That's a slope of flat, slope of 0. But if you have y equals 1x, you get you get a slope of 1. It's exactly in the middle. So there's an infinite number of fractions, right? And you get to y equals 1x. Then you get to y equals 2x, 3x, 4x, 2 million x, billion, trillion, jillion, infinity x. Y equals infinity x is as vertical as you can go. It's the highest possible slope. But what is it? It's a completely straight line where at that point y is divided by 0. No. Is that x is divided by 0?
You're dividing by something
no, the
infinitely small.
It's something's divided by 0, and it creates an asymptote. Right? We're all familiar with the asymptote within the world of mathematics.
Look at like y equals 1 over x.
It's a dotted vertical line, and we call it undefined. But equally, let's think. One limit is infinity. Sometimes the other limit's infinity. Sometimes the other limit's negative infinity. And when the limit's negative infinity, you can see kind of how right at that limit there's a discontinuity. But instead of saying undefined, we could say it's antizero. It's the quantity all. So just like how 0 It's the quantity none, and is neither positive nor negative. There's no such thing as negative zero, or it would just be zero. It's the same thing. It's negative zero. So it's neither positive nor negative because it's neutral. It's the only number that's neutral. In the corresponding way, an analogous way, antizero would be neutral. It would have both charges. It would be both positive and negative. What would this look like? Well, let's think about it. A graph. Y equals 0x. That's neither incline nor decline, right? It's perfectly balanced. Middle, neutral, zero. And what is antizero? It's perfectly balanced vertically because it's both positive and negative. As the reciprocal of zero, it's not neither, but both. And because infinitely up equals infinitely down. And is this making sense to you, Nick?
Yeah, it does. And I think since you come at it both ways, like you can get a vertical line from just having like a very positive slope, or you can get a vertical line from having a very negative slope. Like you say, it has to be both.
Yeah.
So
Negative
for the
a million.
same line, you basically have to identify extremely negative with extremely positive. And you can say maybe you get a circle.
As you get negative million, or negative or positive million,
extended real line.
they both approach a vertical line. So the quantity all would be all quantities. And so the dotted line we draw is actually quite representative of antizero. So I think, why not define it? 1 over 0, reciprocal of 0 as antizero. And this is an insight I had, and because by looking at the asymptote, I just said, what if we could plot that point at infinity? But it would be positive and negative infinity, thus antizero. Or, if you wish, if you rather, it is 1 over 0. It's the definition of 1 over 0. Instead of undefined, we're defining it. So you could call it, because what do you got? A third, a half. This would be a zeroth.
A
Zeroth. Well, a first would be 1/1. But of course, we all know 1/1 is 1. 1 over 1 is 1. 1 is its own reciprocal. Because 1/1
1 into 1
is 1. But a half is not 2. And a third is not 3. And a fourth is not 4. But a 1th is 1. In a similar way as how negative 2 is not 2, negative 1 is not 1. But negative 0, it's 0. It's its own opposite. But it's not its own reciprocal. In fact, there's no farther reciprocals than 0 and antizero. So we're talking about none and all. You know, that's probably the biggest reciprocal pair. I mean, come on, half and 2, and that's not very far away. Third and 3 is...
it's further, but it's not.
Yeah, a million and a millionth is
0
a little farther.
Exactly.
It's as far as possible.
Yeah.
And so that's the basic sketch of antizero. Now, what I want to know is, would this fit into math as it is, or would this create a new type of math?
You know, in the modern algebra, mathematicians are always trying to put things into categories.
Category theory.
Yeah, and there's category theory, and they have like that book. It's like, and they have like the category of groups, the category of rings. It's kind of a misnomer. There's more to it, like groups and group homomorphisms, rings, and ring homomorphisms, category of smooth manifolds and smooth maps between smooth manifolds, the category of sets and functions between sets, and like so they're trying to put constructions into like this different categories. All I have to say about antizero is that it's not going to fit into like a ring, for instance. It's like a ring where you have like addition and multiplication, sometimes division. It's like a field. They talk about localizations of rings, where you like can invert certain elements. If you try to...
What is a ring exactly? Let's break it down.
Well, I'll give you an instance. Like the integers are a ring.
How are they a ring?
You know, yeah, that's a good question.
So
I don't know
integers,
where it came from, the terminology.
1, 2.
I think it was coined by
Positive
Hilbert.
1, positive 2.
it's the thing
So
that
it makes sense
it a
if they're a
ring.
ring, because then
is
infinity,
that-
negative infinity would touch, and
kinda look
at
at
the
it like
point
that.
where they touch would be antizero.
Um,
Because negative infinitesimal and positive infinitesimal
but
are the two limits of zero, the two sides of zero, you could say. The smallest possible thing and the largest possible thing, right? I mean, no. The smallest possible thing, positive and negative, would be the two halves, two sides of zero.
well, that's kind of like going beyond the ring
The
itself.
two
but
limits of
the
zero.
thing that makes it a ring is that it has like additive inverses. So think like 1, -1, like you were saying, 2, -2, and then that you can multiply the numbers. Although you don't necessarily need to be able to divide the numbers. So that's the thing. And you could talk. Every ring has a zero, because you have to have a zero to talk about additive inverses. Like, because 2 - 2, 2 plus -2 is equal to 0. Like that. Two things that add to 0 are additive inverses. You don't need to necessarily have multiplicative verses. So you talk about like there can be rings that don't have one, so like a ring with or without unity. But then, so basically, you can prove that there's something called localization in rings. You can basically invert subsets that aren't invertible. So like you can sort of
Okay, break that down for us. We can
like if you just look at the integers,
subsets.
invert.
We can invert.
You can invert elements of the
subsets.
ring. So like 2, if you just look at the integers, obviously you can take a half, and that's like a number, right?
Mhm.
But if you're just strictly working within the integers, so you just have like 2. There's no half in the integers. There's no half. It's not an integer.
Right.
So 2 isn't actually invertible in the ring of integers. That's the idea. But there's this thing. It's a construction. It's a definition. It's called localization, and you can take things is I can never remember like away at a prime ideal. There's something called a prime ideal of a ring, so there's other things like ideals, maximal ideals.
So you were saying
and
before antizero would not be an element of a ring.
It could be an element of the ring, but it would be the trivial ring. That's basically the theorem. The ring where there's only one element because 1 equals 0. So you can prove in a ring, specifically in a ring,
equals 0.
that if you invert
now that
0,
sounds like a problem.
then you get. Well, yeah, it's not necessarily a problem, but it's just like the uninteresting case. They always consider it.
Sometimes they'll 1 equals 0. That sounds pretty interesting.
It is kind of interesting, right? And like 4 equals 5 or 6 equals 7.
So are you saying if antizero is introduced, 1 equals 0?
If antizero is introduced in a ring, 1 equals 0. So that's why I'm saying to make the concept more interesting, you basically would have to let go of the want for it to be a ring. So I'm saying like it could fit into a modern mathematical structure, but it might just not be like a ring, for instance. You might have to. There's like something called the extended real line, where they add like negative infinity and positive infinity as elements, but then it's like the real numbers themselves would be a ring with addition and multiplication. They'd be even better because you can invert elements multiplicatively. So it'd be what they call a field. Where everything but 0 has an inverse. See, everything but 0. That's like part of the definition of a field. Everything but 0
has an inverse.
So it's interesting.
So
how
if
they
0
kind of
did have an
generalize that.
inverse, 1/0, how would that change things? And could we give a mathematical definition of 1/0?
For sure, there's many possibilities. The question is just which one seems appealing.
Okay, we have options here. Okay, many possibilities.
But yeah,
we choose the most appealing one.
There are spaces where you add points at infinity. There's like projective spaces where like lines like meet at infinity. There's like the Riemann sphere where like the
Riemann
like
sphere.
that includes around. And there's like a point at infinity.
If I
identify
remember
like all possible
correctly,
directions of infinity.
That
as to one
includes
point.
imaginary numbers, right? That's a complex.
I'm not too hot with it,
sphere.
but yeah, I believe so. I believe.
I guess
can
okay.
construct
This is a
it
good question because
complex
if we include complex numbers, 0 is actually 0 plus 0i. So would antizero be antizero plus antizero I?
That's a
because
great
it's
question,
infinitely
isn't it?
right and infinitely up.
Antizero plus antizero.
Because it's the entire all quantities, just like how 0 is the quantity none.
almost inspires like another
Antizero
direction of analysis.
is the quantity all. If none is conceptually logical and consistent, then the quantity all should be logically consistent as well. That's my opinion, at least. But that's what we have Nick here, who's actually trained in mathematics, to ground us in contemporary discussion. And he's saying we not only have the possibility and permissibility of a definition for antizero, but we have options for the definitions of antizero.
I just don't know what they are.
You have something to say? Ethan?
Interject.
Yes.
Do you need a quantity for all, or can you just use a quantifier?
A quantifier.
Yeah.
How so?
Like the universal quantifiers, like upside down A
Yeah.
for like AX. Like that's just quantifies over everything in the space.
Is that for set theory?
Yeah, it's set theoretical.
Oh,
It's
maybe
logic.
that's the set
Logic
theory's
and set
incarnation
theory,
of antizero.
That's fascinating.
Yeah,
Could
so
we
what
make
I'm-
that a number?
Right. I guess what I would want to say is, you would probably have to show that there was some practical. Well, I guess you wouldn't have to, but you would want to know like what
Pragmatism, I guess.
Yeah. What's the utility for mathematics of having a quantity that just stands in for the quantifier?
A correspondence between quantifiers and like
and-
numbers
and-
or
yeah.
elements
Well,
of
as far
some-
as I know, they,
yeah.
I guess you'd want
The
to read
answer-
what Principia. I think
That's
the
Russell
answer to
and Whitehead
those.
talked about how to
really?
how
Whitehead?
derive the numbers, the integers, and all that from
So it sounds
set
like
theory.
so there's the
Mhm.
all.
something like that.
Yeah.
All is a quantifier in set theory.
Yeah.
do.
And
Universal
it's also a quantifier in logic, symbolic
Yeah,
logic.
well, symbolic logic
But
is based on
if
set
you're talking
theory.
about quantities, if you're talking about the answer to the y value in a function, it's just undefined. It divided by 0, undefined.
Right.
So that's what I'm interested in here. Could we define it as antizero? Especially when you see like something going to infinity,
Well, I'm sure
and then
you
it's
could-
coming out from negative infinity. Well,
I'm
where
sure
is
you
that
could
point
make like
there?
a kind of trivial definition, right, and just say 1/0 is antizero, which has something to do with quantification.
Is it trivial until it proves
trivial
a
until we
use
have a thing
in
to use it for?
mathematics?
Would be my assumption. I don't know
Okay.
if that's.
So what about the
if that's good practice,
Riemann hypothesis?
What about it?
That's something people are interested in.
They definitely are.
Non-trivial zeros.
Of the zeta function.
Yeah, could you explain that?
Sure. I mean, the Riemann hypothesis is about the Riemann zeta function. I wish I could write it out.
Right.
But
I
it's
mean,
like-
you can go and
it's
watch
like
a video about
It's like a series. The Riemann zeta function can be defined as a series. There's other ways to define it too, so like analytic continuation. But like,
So what
for
is
instance-
it? So we need to prove that the non-trivial zeros fall on the line.
the real part being 1/2, so it's like a line
Real
up and
being
down
one-
in
okay,
a
right,
complex
because it's-
plane that
because
has
it's two
like 1/2
circles.
plus bi, basically.
Because basically it's two origins at both 1 and 0, and so they intersect halfway is 1/2.
Well, halfway
Right.
between 1 and 0. Yeah, they say all
Right, and so
all the
that's-
zeros. There are other zeros of the Riemann zeta function that are like wacky. But
So
they're,
these are
they're
the
called
non-
the trivial zeros.
These are the non-trivial zeros.
Yeah, they're at like the
Oh,
negative.
okay.
I forget if it's negative even.
This was
integers
just
or-
a first thought.
Yeah.
But the Riemann hypothesis is very interesting. There's actually a $1 million reward out there for anyone who can solve
Yeah,
the Riemann hypothesis.
Clay Mathematics Institute. Right?
Okay, all right, Clay
Yeah,
Mathematics
I think
Institute.
that's
okay,
them.
there you have it.
They've issued it for a
Yeah.
few problems. Seven or so.
okay.
There
P
were
equals
7
NP.
until that one guy solved one.
Oh, that's true. The Poincare conjecture. It was solved by this Grigori Perelman.
He wouldn't take the award though.
Yeah, he didn't want the
Oh.
award.
Yeah.
It's interesting.
Oh.
I don't really know much about that, but like, it sounds like people.
I would have
He had
taken
like a
the
very
award.
personal relationship
honestly.
with the problem, and then
That's pretty noble
Yeah.
of him, I guess. Take the award. But maybe, okay, I'm just spitballing, maybe something like that.
I had a dream
Something
involving that
unsolved
last
could
night.
benefit
I
from
forgot until now.
the antizero. You had a dream about what?
involving the Poincare conjecture. It's kind of random, but I saw a professor
Look
of
at
mine
this. A
at
true
UConn.
mathematics student dreams about mathematical theorems and
Yeah,
conjectures.
it was a pretty interesting dream. Like, my friends were driving away from the parking lot, and I saw this professor that I love, and I was like, oh, can we stop the car? I'll just be 5 minutes. And then I, like, almost got assaulted in the parking lot. It was a very interesting dream. Yeah, I don't remember that much, but very interesting dream.
Interesting dream. Yes.
But, yeah, there was, like, a very, like, simple form of the Poincare conjecture. And I remember in the dream being like, oh, that's basically like a really easy version of the Poincare conjecture. I think I don't know how easy it really was, but it only involved dimension 2. And classification of compact manifolds for dimension 2 is known. It's like a theorem in the textbooks, so it can't be that hard, right? If they know all about it. And they put it in the intro textbooks.
You know what? It looks like we're at 25 minutes here, so I think we're going to close it there. This was about antizero and the philosophy of mathematics. And perhaps we'll have another episode with Nick here about maybe zero, because I think we should devote a full episode to zero, because what an interesting number, right? The only neutral number, and I think we should investigate the nature of zero. Maybe we'll come to a more clear understanding of the nature of antizero, and we could talk about other interesting mathematical philosophy that we think of. So look out for that video that's coming in the future. All right, this has been Mystic Wonder. Thanks for watching.